Alright, so today we're going to go over volume. So let's say you have, you're given a graph here, physical one. So let's say you want to find the area under the graph and find the volume of it if it was rotated about, let's say, the x-axis. In that case, you would take the x values, that delta x, and then you would find the integration of it. So this strategy that's used is, let's say we rotate this graph around the x-axis, it would create a circle type of shape. So it'd be rotated around the x-axis. It would be kind of like a bunch of circles that would mush together into a cylinder of some sort. So the height between the graph and the x-axis is going to be our radius at any given time, which is going to be given by the equation of the graph, which in this case it could be, let's say, 1/2 x plus 2. That would be our radius at any given time, in which we would plug it into this integration formula, a to b of pi r squared dx or dy. Now if we were rotating about the y-axis, we would put dy into there, and we would put this 1/2 x plus 2 in terms of y, and then we'd integrate it for y. So let's start off with number 1 first. So this function here is going to be rotated about the x-axis, which means that it's going to be rotated around here. So it's going to create like a circle type of shape. Now, x squared plus 5 is going to give us our radius at any given time. And our limits of integration is going to be from 0 to 3. So let's first set up the integral. So we have from 0 to 3. And now we want to use pi r squared here, because when you rotate it about the x-axis, it creates a circular shape. So we're going to have pi, and then for r, we're going to use x2 plus 5, or x squared plus 5 rather. So it's going to be x squared plus 5 squared, because r is squared. And then that's going to be dx there. Now we have to integrate it. So first, what we could do is take out the pi, because it's a constant. So we could do pi 0, 3, and then multiply this out, which would be x4, x to the 4th power, plus 10x squared plus 25 dx. And if we integrate it, we're going to have x to the 5th power over 5 plus 10x cubed over 3 plus 25x. And now we need to plug in 0 and 3 for this. And we also have pi, we can't forget about that. So we have pi right there. Now we're going to plug it in first before we multiply everything by pi. But if you also just look at this, if we plug in 0 into all of this, it's going to give us 0 anyway, so we just need to plug in 3. But we could also plug in 0. So we'll have pi, open parentheses, 3 to the 5th power divided by 5 plus 10 times 3 to the 3rd power divided by 3 plus 25 times 3. And that's going to be minus pi times all of this, which would be just 0. This was 0 to 5th power over 5 is 0, plus 0 plus 0, and 0 times 0. 0 times pi is 0, so all this is just 0. Now we need to just simplify this, so if you plug it all into a calculator, you will get 1068 divided by 5, and then we have pi on the outside. So our final answer would be 1068 pi divided by 5. Alright, so let's take a look at number 5 for a second. So for this question, we're just going to set it up. We're not going to integrate it, as it's going to take u substitution and integration by parts to answer it, in which integration by parts is not taught by this section. So let's figure out how to set up number 5. So we have y equals ln of x, y equals 0, and x equals 3. Let's first set up a graph. So y equals 0 is going to be just crossing the y-axis at x equals 0. X equals 3 is going to be crossing the x-axis at x equals 0. So it'd be something like this, let's say. Let's say 3 is right there. And then ln of x would be something like that. So ln of x would look something like that, and we would need to rotate this about the x-axis, in which it would just be this shaded region. Rotate about the x-axis. Now, how do we set it up? So the limits of integration is going to be, we need to figure that out. So, well, I kind of wrote it out already, but we know our end integration limit is going to be 3, because x equals 3 is one of the limits. And then we need to find where it starts. So we need to find when ln of x crosses the x-axis. So if you remember, ln of 1 is equal to 0. So our limits of integration is going to be 1 and 3. And now to set it up, if we use the pi r squared formula, because when we do rotate this about the x-axis, essentially it's going to create a circle with the radius being the area or the distance between the x-axis and the graph of the equation. So if we plug it in, we're going to have pi, and then the radius is going to be ln of x. And let's put it in parentheses, and that's going to be squared and dx. And that is how we're going to set up number 5. Now, again, we're not going to answer this because there's two different types of integrating this, in which it's not exactly taught yet by volumes, by the volume section. Alright, so let's take a look at number 2. So we're gonna have this graph right here rotated about the x-axis, so it's gonna go around this way. Now we're not looking at what we've looked at already. Now the area under this is blank, in which it's not going to be rotated, but this shaded in area is going to be rotated. Now we're given two equations, so we could still use the pi r squared rule, except this time it's going to be like a shell, or rather a washer method. Now what we could do is find the area under the graph of this large equation, and then use that and find the area under the graph under this, and then subtract it from the larger one, which would give us this little area about the x-axis. So first let's set it up. So if we do it, we're going to have our limits of integration is going to be 0, which is when it intersects, and it intersects again at x equals 4. And now we're going to have pi, and the radius is going to be, we're going to figure it out using both these equations. So we have square root of x on the top, which is going to be our top equation. So we're going to have square root of x squared minus 1/2 x squared and dx. Why we do this is because square root of x squared is going to give us the area under the whole thing, and then 1/2 x squared is going to give us the area under this little portion. And this little portion is what we don't want, so we're subtracting it from the bigger one. Now let's start integrating, or let's simplify first before we integrate it. So let's bring pi on the outside because constant. We have 0 to 4. And now square root of x squared is just going to be x minus 1/2 x squared is going to be 1/4 x squared. And all we need to do is just integrate it now. So if we do that, we're going to have pi, open parentheses. Now it's going to be x squared over 2 minus, this is x squared over 4. So if we go up one exponent, it's going to be 4 times 3 on the bottom, which is 12. And now we need to integrate all this from 0 to 4. Now at 0, all this is going to be equal to 0. But all we need to do is just plug in 4 now. So we're going to have pi, open parentheses, 4 squared over 2 minus 4 to the third power over 12. And that would be minus pi, and then you would plug in 0. But in this case, if you plug in 0, you're going to have 0 minus 0, which is all this is just going to be 0. So if we simplify all this, we're going to have 16 over 2, which is 8. and then minus 4 to the third power is 62 over 12, which is going to be, well, 64 actually, yeah. 64 over 12, which you could simplify that to 32 over 6 or 16 over 3. And then that's going to be multiplied by pi. Now, let's figure out what the number inside this parentheses is going to be. So we could make 8 into a common denominator fraction. So it's going to be 24 over 3 if we multiply top and bottom by 3. So 24 over 3 minus 16 over 3 is going to be 8 over 3. And that's going to be multiplied by pi. So our answer will be 8 pi over 3. That's going to be the area of this shaded region rotated about the x-axis. Alright, now let's look at number 3. So for this question, we're rotating about the y-axis. So it's going to create a circle around the y-axis now. But again, we're going to use the same formula except everything's in terms of y. So first, our top equation is going to be this right here. Our bottom is going to be just this y-axis. So our top equation is x cubed plus 1. But let's find that in terms of y. So so we have y equals x cubed plus 1. Let's subtract 1 on both sides. So we're going to have x cubed is equal to y minus 1. We're going to give both sides an exponent of 1 over 3. Because if we give x cubed an exponent of 1 over 3, it's going to turn into just x. So our equation for top equation we're going to use is x equals y minus 1 to the power of 1 over 3. Now let's start setting up the integral. So let's set it up right here. So we're going to have integral of, now we're looking at the y values for limits of integration. So it's going to be where it intersects the x-axis or y-axis to where the integral ends, which is going to be y equals 9. So we have 1 to 9 since it crosses the y-axis at y equals 1. And now let's use the pi r squared method again. So we're going to have pi, and our radius is just going to be one equation, which is going to be just y minus 1 to the 1/3 power, and that's going to be squared. And that's going to be dy. So 1/3 to the power of 2 is just going to be 2 over 3. So we could just write that out again. So it's going to be 1 to 9, integrated from 1 to 9. We could take the pi out since it's a constant. It's going to be y minus 1 to the 2/3 power dy. And now let's integrate that. So if we integrate that, we're going to have pi and then open parentheses. Now y minus 1 to the 2/3 power. What we could do is you could use u substitution. So let's say u is equal to y minus 1 and du is equal to 1 dy. Since the derivative of y minus 1 is going to be 1 dy. So dy is going to be equal to du over 1, but it's just du. So if we replace everything with y, we're going to have pi integrated from 1 to 9. And this is going to be u to the 2/3 power and du. And if we integrate u to the 2/3 power, we're going to have, so we would add 1 to the exponent, which would be u to the 5/3 power divided by 3 over 5. So multiplied by, or divided by 5 over 3, which is multiplied by 3 over 5. And now this is integrated, that's going to be multiplied by pi. And we have to integrate it, or rather plug in 1 to 9. And let's also plug in u before we do all of that. So if we create some space here, or we do have space down here, we could write it out real quick. So it's going to be pi 3 times y minus 1 to the 5 over 3 power divided by 5. And now if we integrate this from 1 to 9, we're going to have pi open parentheses. So it's going to be 3 open parentheses y minus 1. So we're going to plug in 9 first. So 9 minus 1 is 8. It's going to be 8 to the 5/3 power divided by 5. And then that's going to be minus pi open parentheses 3 and then open parentheses 1 minus 1, which is 0 to the 5/3 power and divided by 5. And now 0 to the 5/3 power times 3 divided by 5 is just all 0 times pi is all 0. So this is just, we could forget about that. Now we need to find out the answer of this. So 8 to the 5/3 power, if you plug it into a calculator, it's going to be 32. So 32 times 3 is going to be equal to 96 over 5. And we don't have to simplify the over 5, so our final answer is going to be 96 over 5 times pi.